Whenever you come across a bowl of assorted nuts still in their shell, did you ever wonder, where are the cashew nuts? What most people will not encounter in their lifetime is a cashew in its shell. Before I tell you why this is the case, let's learn a little bit about the cashew. Cashews are the world's most popular and sought-after nut. Cashews grow in the countries along the equator. Some of the biggest producers of cashews are Vietnam, Brazil, India, Ghana, and Tanzania. Cashews are members of the Anacardiaceae family, which also includes pistachios, poison sumac, and mangoes. Cashews grow on trees. Cashew trees prefer well-drained soil, and they are somewhat drought-tolerant. Commercially, cashews are grown on farms and plantations. As with any crop, yields depend on temperature, soil conditions, and proper rainfall. The cashew nut is quite unique. The kidney-shaped seed grows at the bottom of the cashew apple. The cashew apple, known as a peduncle, is a pseudofruit. The apple is actually a swollen portion of the stem. The cashew apple is edible and full of vitamin C. However, the apple does not keep well once harvested. Locals squeeze the apple for its juice, cook into jams, and even make wine from it. Another very important product and the main purpose of this slideshow is cashew nutshell liquid. Cashew nutshell liquid, or CNSL, is a natural phenolic liquid found in the catacomb walls of the nutshell. The reason you do not see shells on cashews is because CNSL is a caustic liquid and a skin sensitizer. If one ingests CNSL while eating cashews, most likely they will have an allergic reaction such as rashes and/or swelling of the air passages. Very sensitive individuals, asphyxiation can occur. Cashews are a very labor-intense crop and require great care to extract the kernels. The cashew nut is composed of, by weight, 50% cashew nut shell, 30% kernel, and 20% CNSL. The kernel is separated from the nutshell by a thin paper layer called the testa. Many countries still extract the kernels manually. Nuts are placed into a hand or foot-operated press. The sharp-edged press applies pressure to the edge of the nutshell and splits it into two. The kernels are usually plucked from the shells with a metal pick. Over the years, companies have come up with creative ways to mechanically separate kernels. One way is to load large amounts of nuts into heated vessels. The nuts are heated to high temperatures, causing the shell to rupture and release CNSL. The broken nutshells are further processed to get the kernels. Once the prized kernels are collected, the nutshells can be further processed to capture the CNSL. Let's look at the chemical structure of CNSL. Heat-processed CNSL is primarily composed of cardinal and cardinal. Cardinal, or 3-pentodecanylphenyl, is a phenolic molecule that has a 15-carbon meta-substituted aliphatic side chain. On the side chain, there is 0 to 3 double bonds. The average is 2. Cardinal, or 5-pentadecanyldienyl resorcinol, is a 15-carbon meta-substituted resorcinol compound. It has 2 double bonds on the side chain. This compound causes skin irritation. Once the molecule is reacted into a polymer, skin sensitization is dramatically reduced or eliminated. CNSL has many industrial uses. One of the world's largest purchasers of cashew nut shell liquid is Palmer International Incorporated, located in Skipack, PA. For over 65 years, Palmer has specialized in making value-added products with CNSL. Palmer purchases 6,000 to 8,000 metric tons of CNSL per year. Tank ships deliver 1.5 million gallons of CNSL at a time to a storage tank at the Port of Philadelphia. Palmer International processes and refines CNSL to make friction particle, phenolic adhesives, epoxy curing agents, air dry resins, and surfactants. The biggest demand for CNSL is the automotive industry. CNSL is a polymerized and reacted to make friction particle. Friction particle is a sacrificial component of a brake shoe that provides heat resistance, friction, and lubricity. CNSL can be used to prepare heat-resistant Novolac and Rosalic adhesives. These compounds are sometimes used as binders in brake shoes or pads. Raw CNSL is a dark brown liquid. Palmer International has a distillation unit that strips out an amber color fraction of CNSL. This refined distillate is used to manufacture epoxy curing agents and air dry resins. CNSL distillate is used to make epoxy curing agents called phenalkylamines. These materials are used in two-component epoxy coating systems. Phenalkylamines offer better low-temperature cure than other curing agents, and they make excellent marine coatings. Palmer has joined forces with Royce International in manufacturing a line of phenalkylamines. CNSL distillate is used to make air-dry resins for inks and coatings. Cashew resins is a line of products based on polymerized CNSL. They are used as reactive diluents or co-resins in air-dry systems. Cashew is currently used in sheet-fed printing, floor and furniture finishes, primers, stains, and paints. Cashew brings a new technology to an ever-changing industry. They offer the following benefits: green chemistry, made from renewable resources, can lower VOCs, imparts good film hardness, improves dry times, provides solvent resistance, and has excellent gloss. We hope you found this slideshow enlightening and will tell your colleagues and friends about it. Zownet Chemicals is proud to represent cashew resins for Palmer International. To contact someone at Zownet, please contact Greg Zapp. For more information regarding Palmer's friction particles and adhesives, contact Andrew Masloff. For more information on Royce's phenalkylamines and other epoxy curing agents, contact Aman Singh. Thank you for your time.